Hello friends, welcome to 30 Minutes Learning. In this session, we'll talk about Selenium and web automation with Cucumber. You can download the Chrome driver from chromedriver.chromium.org. Before you select a specific version, make sure you check the version of the Chrome. Here I'm using 83. So for us, the right version is 83, not 84. And you can select the build as per your operating systems. Once you have downloaded, put it in a path where you want to keep the driver. And we'll be using that path. We have to set up the dependency in the project, in the test project. So we can copy this. Here the version is not there. We can take help from Maven repository for getting the right version. So this is the version that we can use. And I have copied it and put it in the test project. This is the project that we used for our previous 3 discussions on the BDD with Cucumber. We had on the rest assured and the advanced versions of the Cucumber. So if you haven't looked at those, find the link in the I button. We downloaded driver for Chrome since we are going to verify our application in Chrome. However, the dependency that we downloaded is Selenium Java. It will support all the browsers provided we have the supporting driver for the browser. The web driver does this. It provides an interface between the framework and the browser. All the commands is executed via this driver on the browser. And these are the browsers supported by Selenium. And we need to download the respective driver of the browser. Let's look at the application that we are going to automate. We have a to-do application developed on Angular on the front-end side and Java Spring Boot on the back-end. This application has 3 tasks. One is to add a task. When we create a task, this makes a post call. The URL we're using is /task. Method is post, and this returns you 201. Let's look at the request that was sent for adding a to-do. We are sending task name, create a session in the payload. We can do 2 more actions on the task. We can delete a task or we can mark this task as done. When we click on the checkbox, we make a patch request to /task. Request method is patch and the response that we got from server is 200. And we are sending this request body to the server. And when we delete the task, we send a delete request to the task name as part of the path variable. And we send a request method delete and a status code that we get is 200. If you want to understand how should we design a resource, please go through my video on Richardson maturity model for REST APIs. In that video, we talked about how we should define our APIs, API resources. Now let's start automating the application that we talk about. First of all, we need to register the WebDriver for Chrome. We can set the property, system.setProperty. Property name is webdriver.chrome.driver. And the value would be the path where we have saved our Chrome driver. One way of setting the path for Chrome driver is this, using system.setProperty. All we can do is we can set the environment variable and we can give the name of the variable as webdriver.chrome.driver and the value is the path. Make sure you provide the application name in the path. After setting the path, we'll create an instance of Chrome driver that will be of type WebDriver. Let's organize the imports and we will ask driver to make an API call. We will now wait for the page load. We can do like this, driver.manage.timeout.page load timeout. Here we'll specify the time here. So that will be say 3 seconds, 3, and the time unit will be in seconds. Now we'll find the element where we can type the task name. We can take help of find element that is available in the driver. Find element and find elements. Element is when we try to find an element by ID. Generally we get unique, that is 1 element. And if we try to find by CSS or with a matcher that could provide you more elements, we use find elements. By dot ID, we specify the ID of the attribute here. Let's go to the page and see what is the ID. That is task name. We'll put the ID here and we'll assign it to a web element. That's the one way of locating the element with the help of WebDriver instance object. Here WebDriver represents the browser and web element represents a particular DOM node. It could be a control, for example, link, input field, button. Let's understand what all elements do we have in our application. Input text box, which has an ID of task name. So the unordered list has an ID of task list, and each list item will have an ID of the respective task name. We'll use the same snippet. We'll say task. Once you have a reference to a web element that has been found, you can narrow the scope of your search by using the same call on that object instance. We have the task list with us, contains list of tasks, and now we are trying to pull one task unordered list. So we can do is find element by ID, and as we know, the ID of that element is task. We can do this because both the WebDriver and web element types implement search context interface. In WebDriver, this is known as role-based interface. And by interface also supports a number of additional location strategies. Here we have by ID, class name, CSS selector, link text. For the link text, it has to be the same match, otherwise it will not find. We can find by the name attribute, the partial link text. We can use the tag name and the XPath. In line number 22 and 23, we are pulling the web element on the individual lines or the separate lines. We can club line number 22 and 23 into one statement. Here we will use CSS selector. To improve the performance of your application, we should try to use more specific locators. WebDriver supports looking up elements by CSS locators, allowing us to combine two previous locators into one. We discussed how we can select one element from the DOM. Let's understand how we can select multiple elements. So what we have to do is on driver, we will do find elements and we specify the selector. We'll use CSS selector. We'll use unordered list ID and we have li element. So this will give us a list of web elements. This method returns a collection of web elements. If one element is found, this will still return a collection of one element. If no element matches the locator, an empty list will be returned. In general, if HTML IDs are available, unique and consistently predictable, they are the preferred method for locating an element on the page. If the unique IDs are unavailable, a well-written CSS selector is the preferred method for locating an element. Now let's talk about the actions that we can take on the elements. The first action that we can do is send keys that will push the text that you put to a specific element. Task name reference, you can use task name dot send keys and we can pass the string that will move the text, that will push the text to the specific text box or the input box. There are some web applications which uses JavaScript library to add drag and drop functionality. So this will perform a drag and drop from source task name to task list. Another operation that we have is click. This is our web element for the checkbox. And to check this, we can do task dot click. Now we have understood the basics for working on Selenium for doing web automation. Let's quickly automate a task of adding a to-do action, and then we will do the same using BDD feature file. We are sending new task and the enter key. So this will push new text and will replicate the user behavior of hitting an enter on that field. And with this code, we are waiting for 5 seconds. And to observe the action taken by the script, that is, the new task should be present as part of the list. And we will quit the driver, quit the browser. Let's run this. And this should create a new task. As you can see, this created a new task. Now let's write the feature file, which will automate the process of adding a task to the list. And we'll verify using the web element if the requested task is added to the list or not. Also, we can verify in the service response using REST assured. So let's implement both in this feature file and see how it goes. So the feature file name would be to-do, the to-do app. Let's remove, rewrite feature, to-do app, select the scenario, add a task to the to-do list. Given I have a task, say by EV, when I hit enter on the task field, then the task should be added successfully. Let's give this feature file a run. That will give us the stub, and we'll write the step definitions for those steps. So we have created a step definition file that is two-row step definition. We'll paste copied stubs, organize the imports, and we'll clean up the stub code that we got. And here we'll initialize two things. First is a driver, and second is the rest assured objects required for verification of service data. We will use before and after hook for setting up the required objects for web automation and service automation. Okay, the code is ready, which is automating a step for adding a task to the to-do list. Let's go through the code. I've mentioned three attributes. Request specification is for validating the service response. WebDriver handling the interaction with the web browser. And task name is the one which will hold the value that we get from the given step. So we are using before and after hooks. In before, we are setting up the project. Here we are setting up the path for the Chrome driver, and now we are initializing the Chrome driver object. We are first initializing the request specification, assigning the task that we are getting as part of the input to this step, and we are calling the UI. And after UI, we are waiting for 5 seconds to load the page. And in the when, we are taking a reference to task name attribute, and task name is the ID of that input field, and we are passing the input task name, and we are hitting the enter after that. And in then, as of now, I've done is validation of the input response via rest assured. I'm converting the input to an array, and with request specification object, I'm making a service call, and in the task name is the body that we'll be getting. Let's see the response. So task name is the object attribute, what we are expecting in the path, in the body. And in the after teardown method, we are waiting for 10 seconds and then closing the browser. Let's give this feature file a run. It started the browser. So after 10 seconds, it quit the application. Now we'll discuss the DOM validation. First, we are pulling out the task list, that is the unordered list by ID, task list. Then we are pulling the task item from the task list. So we are doing task list.find element, and that is the element ID is the task name. And from the task item, we are pulling out the label by ID task label underscore the name of the task. And for that ID, we are getting the text and matching the text with the one that we are providing in the test step. So let's give this scenario a run. This added the text, and now it's waiting for the timeout. Now let's look at this response that we got here. So we had given when and then, and one scenario, all three passed successfully. Say if I give any of the wrong value for validation, like task name, and I append something like 1, 2. Let's give this feature file a run. It added a text, but the response validation will fail. That we expected this. 2 steps passed and 1 failed out of 3 steps. This is the last step which failed because of DOM validation, and the API validation passed successfully. In the after teardown, we can record the screenshot of the application so that we can put this in the report to append a screenshot to a failed scenario. We can do that in the @after hook, where we'll check if the scenario has failed. With the help of the driver, it will take a screenshot, save it as a byte, and with the help of scenario embed, it will put that byte into the scenario report with the name of the scenario. It will only append the screenshot when there is a failed scenario, otherwise it will not. We have put a tag @web, and in our test case runner, we have put a tag @web, and it will run only that scenario, right? So let's give this a run. We'll say mvn test. It will start the browser, and the scenario failed because we have put the hard-coded 1, 2. And the moment it failed, it took a screenshot and embedded to the scenario. Let's open the report. Target reports HTML. So this is how the report is with the feature. Since it failed, it is in red. All the bars are in the green. It puts a screenshot as well as reason why it failed. It has the comparison failure. Thank you for watching this session. If you like this session, please like and subscribe to my channel for more videos.